Part 3, REST and other approaches. Now, REST is a very complicated name for something that's actually trivially simple. So it stands for Representational State Transfer. In reality, it's a simple CGI script that, instead of returning HTML, returns something that is easy for you to parse. So that might be XML, it might be something like JSON, or simple keyword : value type representation of the data. REST then, from the user's point of view, from the client's point of view, is a simple variation on screen scraping. It relies on the service provider to provide a version of a CGI script, and that might just be that the CGI script takes another parameter, or it might be something a bit more complicated than that. But the service provider has provided this script in a way that is designed specifically for remote access. The client then is identical to the screen scraper client, but you're guaranteed that the results will come back in some sort of simple to use fashion that is easy to parse, and you can then just get those results back without having to worry about HTML and having to worry about the format of the results changing. From the server's point of view, the service provider needs to provide a modified CGI script that returns this plain text. And as I said, that can just be an option given to the CGI script. So there are many, many examples of REST that provide services for bioinformatics. So, for example, the Entree programming utilities provided by the NCBI. So, for example, if you wanted to search their PubMed database of publications, you would start by providing a string in a particular format, and you would get back XML containing a list of the PubMed identifiers. And then you could take each of these in turn and obtain the results for each PubMed ID. Now, I've provided a script online that you can try in order to extract papers from PubMed. This is actually written in Perl, not in Python, but it's showing you the sort of thing that you have to do. And you can access that via the practical web page. You can also try out web services that we have provided for a number of our different facilities, including PDB Swiss, which is a mapping between PDB entries and Uniprot KB/Swissprot entries, and our ABDB resource, which is a resource of antibody structures that have been pre-numbered. The next approach is to use some sort of custom code. Now, I'm only including this really for completeness because it's complicated. It's not really something that people tend to do when they're doing web services, but sometimes it can be useful when you're writing something locally that is sharing a load between multiple computers. So, as I said, this is generally used to distribute tasks on a local network. However, the code is largely quite complex. It requires low-level operating system calls. And again, I have put a sample on the web in case this is something that interests you. So when you're doing this, and indeed when you're doing any connection over a network, the link between the computers relies on having an IP address and a port number. So ports are tied to particular services. For example, port 80 is HTTP. Port 22 is SSH, which you can use for logging into remote computers and so on. So if you're logged into a Linux computer, you can have a look at the file /etc/services, and that will give you a list of the port numbers for all the services. So if you're trying to create a connection between two computers, you need to specify the IP address of the remote computer and a port number that you want to make that connection over. So typically what you would do is look in /etc/services for the well-known ones that are used for well-known pieces of software, and you would then specify your own port instead. Now, probably the obvious time where you might have used something like that is in accessing a MySQL database, where you can specify a port number for the MySQL database and an IP address for the database, so that your client software is running on a different machine from your actual database server. Now, generally when we do this sort of thing, we're using some sort of client-server type model. The server sits and listens for messages, and the client makes a request to the server. So we've got our server over here sitting and waiting. The client sends a request, and the server sends a response. Sometimes both ends can act as both clients and servers, so that they can both kind of initiate a conversation. So what happens is that the server creates what's known as a socket and binds it to a particular port, and then it sits and listens for connections from clients on that port. It responds to the messages received and replies with information sent back to the client. At the client end, you also create a socket and you bind it to a port and IP address on the server. So the client end sends data to the server, waits for a response, and does something with the returned data. Now, as I said, I've only really included that for completeness. There is some code that I have put on the web, and that code is in fact written in the programming language C, so it would be only really of interest to you if this is specifically something that you need to try to do. Standardized methods. Well, there are various methods for doing this sort of thing, for connecting to remote computers. I think the earliest one was called Corba, and that's rarely used now. It's fairly tightly tied into the Java programming language. XML RPC is XML remote procedure calling. That's again something that isn't very widely used anymore. There's something called SOAP, which we'll go on to describe in a little bit more detail in a moment. And there's a fairly new approach called GraphQL, which I will also describe. So SOAP is the idea of having some sort of application client talking over a web service to application code. And the thing that's kind of special about this is that the two applications, the client end and the code end, talk to each other using messages in XML. So the information is encoded in XML, and the advantage of that is that it is language independent and all the data are transmitted as simple text. SOAP is in fact just a packaging protocol. So it's a way of packaging up data, including variables, and it has a standard way of encoding things like integers, floating point numbers, strings, arrays, hashes or dictionaries, structures, and so on. And all these things are packaged by using XML. Now this SOAP packaging protocol sits on top of some sort of networking and transport protocol. And SOAP doesn't actually care what these are. But typically it's HTTP over TCP/IP. So TCP/IP is the standard way of making connections between computers, and HTTP obviously is the Hypertext Transport Protocol, which is used for the web. So an HTTP post request contains a SOAP request that goes from your client end to your server end, and the HTTP response contains the SOAP response. Now, the way that SOAP messages are structured is actually very similar to the way that HTML is structured. So there's what's called a SOAP envelope, which is similar to the HTML and end HTML tag that's used for HTML. There's an optional header, which is just like the head and end head tags in HTML. And there's a SOAP body, which is just like the body and end body tags in HTML. So the structure is very, very similar. So the header can do various different things. It can be used, for example, for specifying that the data and what's returned must be handled as a single transaction. And the body can just contain simple data like a sequence encoded in XML, but more commonly we use these special SOAP variable tags that allow us to define the type of data that's being sent. So in order to implement a SOAP server, we need to have some sort of listening protocol, such as HTTP, and that could be a normal web server, such as Apache. That's the sort of standard web server that's most widely used. And then we need what's known as a service proxy. The job of the service proxy is to dispatch the requests to particular bits of code. And that is normally just a SOAP-specific CGI script. You just have to provide a CGI script, and then the actual application code simply sits as modules or libraries which can be accessed by the CGI script. So there are lots of libraries available for different programming languages that allow you to implement SOAP servers really very easily, and indeed SOAP clients as well. And some of these libraries are written in such a way that if we were doing our secondary structure prediction and we had a subroutine called predict_ss, as we saw earlier, that predict_ss routine could be your application-specific code on your SOAP server, and you can set things up in such a way that you just call that routine within your code in Python or Perl or whatever language you like, and the library is clever enough to realize, oh, that doesn't exist here. I'll have a look on the remote server instead. So from your client's point of view, apart from setting some things up at the beginning, all you have to do is call a function. However, as nice as the SOAP idea is, it never really caught on in a big way because it is relatively complicated to implement, even with the libraries that are available to make that easier. And SOAP was one of the enabling technologies that was supposed to work with the idea of the semantic web, but again, that never really took off. And instead, people focused on something much simpler, which was this REST idea that I've already talked about. Now, both SOAP and REST actually have some fairly major limitations. And those limitations revolve around the fact that the service provider needs to have a very clear idea about what the client is likely to pass to them and request from them. And that often means that we have problems of underfetching. In other words, by doing a single query to the web service, we can't get back all the information that we need. And equally, there can be problems of overfetching. In other words, you have a function that provides lots of information, but you only need a small part of it. And these limitations have led to this new standardized method for accessing data and accessing methods on a remote computer, which is known as GraphQL. It's only been around for a few years. I think the first books on using it were published in 2018. And I have to admit, I'm only just starting to get to grips with these ideas myself. This is something that one of my PhD students has used quite a lot, but it's not something that I have used extensively. So the idea with GraphQL is that you can create a GraphQL service by first of all defining the types and fields on those types. So a type is a bit like an object, and you can have fields within that object. And secondly, you need to provide functions to handle each field of each type. Now, you don't have to combine these things or worry about complex kind of queries that combine them in different ways. You just have to provide a function that can return a particular field for a particular type. And I'm going to recommend that you have a look at this graphql.org/learn webpage in order to find out more about this. But I'm going to take some little extracts from that just to show you the basic ideas. So here's an example of a GraphQL service that tells us who the logged in user is, in other words, you yourself, and that user's name. So we would have a type called query, which has a field called me, so this is who I am, and that contains an object called user. So user is this type is essentially an object, and we can nest these within one another. So we then define the type user as having an ID, and that is some sort of identifier, and a name, which is a string. So that's all we have to do in order to define what the GraphQL service looks like. This is obviously a very simple service, doesn't do very much. And we then need to define functions that implement this. So this happens to be written in JavaScript, but it could be whatever language you like. Essentially, we have a function called query_me. So that's relating this type query to this field, me. It takes a request and it returns request.auth.user. So this is something that is in this request object. Auth means authorization, and this is the user object which we can look at. Now, we also have a function called user_name, so that comes from here, user and name. So if we're wanting to get the username, we would take a user and we would call this function called getName based on this user object. And we could similarly have a user_ID, which would take the user and get the ID. So we have a set of functions which implement the returning of data. And obviously I haven't gone into how these items of data are populated or anything like that. It's just how you would return the information. So how would you query this? Well, what you do is you build up a query which is all in these kind of nested brackets, and to query that very simple GraphQL schema which I've shown here, all you would do is say, give me the name associated with the me field. So that would be the name associated with me. Now, that actually involves going through some nesting, because me is actually an object called user, and so it would jump from this me to the user object, and then it would return the name from the user object. So this is why it's called GraphQL. It's effectively a graph, a set of items or nodes that are linked by edges. That's a term that's used in graph theory. So we have this as one of the nodes, this is another node. They're linked together by the fact that we've got the word user in here, and that's the type of this item here. So running this query, if we only had one item in our data set, would simply return something that looks like this. Me, colon, name, colon, and the name of the person. Now, GraphQL is really just then about asking for specific fields from objects. So if we had a query like this, so this is a different schema of a graph, and we requested the name of a hero, so we might have heroes in our data set, and this might be a nested thing where we have an object called data, which contains an object called hero, which contains a field called name. So we could do a query like this, and we'd get back something that looks like this. But the key point about this is that the query and the result have exactly the same kind of shape. So in this case there was a layer above this, so this data thing was above hero and name, but the shape of this is followed by the shape of this. So that means that you always get back exactly what you expect. So in that previous example we requested a name and we obtained a string type of item back, but as we've seen, the fields can also refer to objects. And on that basis you can make subselections using fields of those objects. So GraphQL queries can traverse this tree of related objects and their fields, and that allows clients to fetch lots and lots of related data in a single request instead of having to make several requests as would be necessary with classic REST or SOAP or something like that. So in this case, this hero, so we only had one hero in our database, and that hero, we're pulling out that hero's name, but we've also got a set of friends of that hero. So this is an object, and we want to pull out the name of those friends. So this is actually an array object, and so we're getting back the outside data wrapper. We're getting hero, name, just as we had here, R2D2, and friends, and then we're opening an array, and we have Luke Skywalker, Han Solo, and so on. Now in GraphQL you can also pass arguments to individual fields. Now in REST, of course, you can pass a URL, and you can pass some query parameters in the kind of get style notation, so a question mark and then a field equals value, ampersand field equals value, and so on. But whether those are useful or not will depend on how the person has implemented the web service, because that will define what parameters are actually understood. In GraphQL, you can explore every parameter and argument across the whole kind of tree of data. So every field and nested object can get its own set of arguments. And this then, of course, replaces having to make multiple REST API fetches. So in this example, I'm looking at my same kind of data set again, and I'm specifying that I want to have a human with an identifier of 1,000. And for that human with an identifier of 1,000, I want the name and the height. So you can see this is a little bit like a normal sort of database query language like SQL, but obviously the format's very different. And what comes back from this then would be data, human, name, and height. Now, I've only kind of touched the surface of this because largely what I'm talking about here so far is returning data that might be in a database, might be just in some sort of internal data structure. But GraphQL also allows you to do things like posting data to the server so that you can do the same sorts of things that you might do with a CGI script in order not just to access a database, but to do calculations and so on. And it even provides methods that will automatically deal with the problem of calculations that take a long time, in that you can call GraphQL's function, send it the data that you want to do your calculation on, the remote server does its calculations and wakes up the calling code when those data are available. So GraphQL is really extremely powerful. It's relatively easy to use once you get your head around the format it uses. It gives you lots of options. It allows you essentially to replace a set of functions that you might have to implement for REST or for SOAP with just a single interface, because you can specify at any depth within the data what you want to set, what you want to restrict, and what you want to get back. So take a look at this website which describes the GraphQL language, and again there are libraries available for most programming languages that allow you to implement this within a CGI script and to implement client code that can deal with these sorts of things very easily. In summary then, remote procedure calling allows access to methods and data stored on remote computers. There are four main ways of achieving this: using screen scraping, using REST, which is just a special CGI script where instead of returning HTML you're returning plain text, which might be XML, it might be JSON, it might just be keyword : value pairs. You can implement custom code, but unless you have a real need to do so, that's probably not the route to go. And you can use these standardized methods, of which GraphQL and SOAP are the most popular. GraphQL so far I think has only been used in 2, maybe 3 bioinformatics applications. SOAP has largely died out from a bioinformatics perspective and been replaced by REST, but a number of websites are starting to think about implementing GraphQL as a more flexible approach than using REST. So SOAP has not caught on as much as was hoped. REST is much simpler to implement and to understand. REST is simply a CGI script. GraphQL is a new REST-like approach that overcomes some of the drawbacks of REST and allows you to access data and calculations in a much more flexible way. Just to point you to a few books then, they're all published by O'Reilly. This first one is about screen scraping using Python. Second one here about creating REST servers. This one about creating REST clients, and this one about GraphQL.